America is the leader in space exploration. The NASA-funded ATLAS survey telescope in Chile reported its first observations of the comet to the Minor Planet Center on July 1, 2025, and NASA has been tracking and studying Comet 3I Atlas ever since. Today, we want to share with you the latest information about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small solid object made up of a mixture of rock and ice that vaporizes when it gets hot, like when it's near a star like the sun. But to start, I want to get the rumors out of the way. I think it's important to talk about that. This object is a comet. It looks and acts like a comet, and all the evidence points to it being a comet. NASA's message was simple enough to make headlines. 3I Atlas is not a threat to Earth. But the message was at odds with the actions that followed. While the public was reassured, the International Asteroid Alert Network, IAWN, quietly launched its largest tracking campaign in years. Observations were accelerated, telescopes were reallocated, space equipment was repositioned. What had started as a routine interstellar visitor suddenly required 24/7 monitoring, while NASA maintained a calm, almost dismissive tone. It was in the tension between words and actions that the real scrutiny began. The whistleblower's post, which went viral on social media, raised public anxiety levels with a blunt message. 3I Atlas does not behave like a normal comet. It does not appear as a neat point of light, its peak brightness fluctuates erratically, and its shape repeatedly bends orbital calculations. These warnings are not just imaginary. Experienced astronomers also admit that 3I Atlas does not maintain a shape and a brightness curve that fits familiar sublimation models. Photometric measurements repeatedly appear to be unstable, forcing repeated adjustments. Something is amiss with the behavior of this visitor, rekindling the controversy surrounding 1I Oumuamua. Is it just a natural oddity or the remnants of an unnamed physical mechanism? Meanwhile, NASA's repeated assertions of no threat coincided with a rapid acceleration of the IAWN campaign, with more observatories, more observing time, and more frequent orbit updates. In reality, space agencies rarely commit such resources unless they believe the margin of error is worth minimizing. The urgency flared up just as 3I Atlas approached Jupiter, making the secrecy less like normal caution and more like a race to decipher what was happening. On scientific forums, hypotheses ranged from strange matter structures, anti-gravity, to conspiracy-laden scenarios. But for now, the only certainty is that 3I Atlas is forcing astronomers to reconsider what they thought they understood about interstellar visitors. Standing between the alarmist rhetoric and the observational data is astrophysicist Avi Loeb, who has quietly compiled a list of 3I Atlas's anomalies. Loeb is known for being both open to unconventional explanations and controversial, but his insistence on letting the data speak for itself makes his analysis a must-read among experts. From the start, he points out that 3I Atlas doesn't fit into any standard catalog. As observations accumulate about its brightness, shape, response to gravity, and non-gravitational effects, the object slips out of every familiar classification drawer. At the border between mainstream science, academic skepticism, and a wave of online conspiracy theories, the question hangs in the air. Is 3I Atlas a natural anomaly or a sign of something that current classifications aren't designed to name? One of the earliest signs of something unusual came from 3I Atlas's orbit. Interstellar objects are already extremely rare, but this stranger was flying off its usual path, as if some invisible force, in addition to gravity, was silently pushing it off course. This is not unusual for comets, which can be pushed slightly off course by outflows, but with 3I Atlas, the magnitude and pattern of acceleration did not fit any of the standard outflow scenarios. Avi Loeb notes that if the comet were simply an evaporating comet, the distribution of sunlight, thermal reactions, and thrust should have produced a relatively stable effect. Instead, the deviations were so erratic that every orbital solution had to be constantly tweaked, the model failing, patching, and then breaking again as new data emerged, as if the object were choosing its own path or being influenced by something outside the normal cometary framework. The shape and brightness add to the puzzle. Instead of a clear nucleus peak amid a diffuse haze, 3I Atlas's peak fluctuates, sometimes off-center, sometimes blurry, sometimes obscured, the nucleus unclear or elongated. Images from amateur astronomers reveal a carbon-rich greenish glow typical of a comet, but lacking the symmetry of a simple evaporating block of ice. If the object were simply tumbling, its light curve should show a clear cycle. Instead, the variations are erratic, suggesting a peculiar nucleus or a distribution of reflective material that rotates in unpredictable ways. Teams have tried everything from elongated and rugged to multi-component, but none of the models have held up as the data have updated. Then came the term horizontal lines, which quickly spread through the online astronomy community after narrow streaks appeared near the comet that didn't match up with background star motion or satellite interference. Loeb openly raised the possibility that these were smaller objects ejected from 3I Atlas, delicate debris, or potential satellites. The idea sounded dramatic, though thermal fragmentation is not uncommon in comets. Debate erupted. Some argued they were processing noise, others agreed they were real but harmless. Despite the differing interpretations, their timing and their close association with the comet's position were enough to push the horizontal lines into the ever-growing list of anomalies, where each new detail inadvertently fueled both the scientific community and conspiracy theories surrounding the true nature of 3I Atlas. The mystery surrounding 3I Atlas deepened when the first batch of high-resolution HiRISE images was unexpectedly delayed. Avi Loeb publicly criticized NASA for holding back data taken weeks earlier, insisting it was key to understanding the object's physical structure. HiRISE, which specializes in imaging the Martian surface, took advantage of an extremely short observation window to capture 3I Atlas, just when its shape would reveal rare, sharp details. But the images were not released to the public as originally scheduled. Whether the cause was procedural, shutdown effects, or deliberate caution, the lack of critical data at a critical time has created fertile ground for speculation. The lack of transparency is not proof of anything unusual, but enough to keep the story hot. Each individual anomaly has a natural explanation. Comets breaking up under thermal stress, falling off course due to irregular shapes, jets of material skewed, measurement noise, data delays due to multiple agencies processing them. But put them all together, and the picture becomes harder to ignore. Instead of converging on a stable pattern, the anomalies are increasingly dividing apart, like a jigsaw puzzle with pieces from multiple boxes. Even cautious astronomers have to admit that 3I Atlas is not like Oumuamua or 2I Borisov. It is in the same interstellar family by definition, but it lacks the obvious cometary characteristics of Borisov, nor the easy-to-decipher reflection patterns of Oumuamua. It drifts in a gray area between the familiar and the unseen, becoming more ambiguous the closer you look. The uncertainty grows as 3I Atlas enters close contact with Jupiter, where its immense gravity can bend, accelerate, or even capture passing objects, and it serves as a crucial test. If post-close behavior deviates from simulations, the anomalies will be hard to dismiss. If it matches the models, many speculative concerns will subside. Astronomers await post-close data, some with professional curiosity, some with an unnamed sense of unease, while the public treats the void as fuel for the imagination. Most experts remain firm. 3I Atlas is an unusual object, more unusual than most comets, but strange does not mean intent or threat, but rather a reminder that nature still has unexpected moves at the edge of interstellar space. Still, the sudden increase in monitoring iterations, the growing list of anomalies with each observation cycle, the gap between reassurances and on-the-ground action, the string of unanswered questions, and the delay when transparency is most needed have created a thinly veiled tension in the community. Loeb sums it up coolly but hauntingly.
On March 16, 2026, it will come close to Jupiter, within 54 million kilometers from Jupiter, and there is a spacecraft orbiting Jupiter called Juno that we hope that NASA will use to learn more about it.
While the world awaits the data from its Jupiter close-up, along with new images and measurements, 3I Atlas still straddles the line between science and speculation. It could be just a particularly unruly chunk of interstellar ice, crumbling and venting chaotic gases after millions of years of wandering, or something that fundamentally challenges current models. Every interstellar object is a test, and the central question remains open until more data arrives. Is 3I Atlas a normal object with unusual behavior, or the first alien messenger that refuses to play by familiar rules? For now, it quietly drifts on, carrying with it a mystery that neither whistleblower nor the scientific community can fully grasp.